Let's begin. So, before we tackle this question, let's go through what I taught yesterday or try to revise. So let's recap. What's the inverse matrix formula again? So A inverse is equal to what? Can I please have Zahn? Fantastic. This is your inverse matrix formula, and you know that matrix A is given by a 2 by 2 matrix where you have A, B, C, D. Okay? And it will only be a 2 by 2 matrix in this case because you're working with simultaneous of linear equations. So you only have X and Y. You only got 2 terms there. Okay? So it's a 2 by 2 matrix and you get 2 equations. So row 1 for equation 1, row 2 for equation 2. Okay, you got 2 columns because you've got 2 variables to deal with. All right, and we're not doing a 3 by 3, but if you are doing a 3 by 3, it's a calculator work. So any manual work is done with a 2 by 2. Okay, so this is it. Now, there's a couple of things that we learnt. We learnt determinant of A. What is the determinant of A equal to? Can I please have Phoebe? Good. AD minus BC. What does the determinant tell me? What does it tell me, Jack? How many intersections or solutions we've got? How do we know? What do we tell? So yes, it does tell you whether you're going to get any intersections or not, but what do you look for? What do you look for, Naz? Determinant of A. So we said it's going to tell us the number of intersections. So how does it tell us the number of intersections? What's the thing we're looking for? Say it again. Whether it equals to 0 or not. So whether the determinant of A equals 0 or not. Why does it matter if it equals to 0, Rachel? Say it again. Okay, what doesn't exist? The intersections don't exist, but how do we know? What are we looking at, Anne Sarah? Fantastic. So this is all tying together. We're saying this is the A inverse formula, and what we can see is AD minus BC is really just this denominator that we gave it a name, we said that that's a determinant. What are we determining? We're determining whether there's an x-intercept, not x-intercept, there's any intersection or not, so you get a solution or not. So it says here, how do we know? As you said, you're just saying, is it equal to 0 or does it not? Because when it equals 0, then you got 1 over 0, you got an undefined answer. So what do you have an undefined answer for? You have an undefined answer for the inverse. That means the inverse is undefined. Now this is key, because if the inverse is undefined, that creates a problem. Okay, and what is the problem? Well, the problem we usually have is you have 2 simultaneous equations. You've got A multiplied to X gives you B. The only way to get matrix X is if you remove A. The only way to remove A is if you had an A inverse. You need this to be defined. If you can't find the A inverse, then that means you can't find out X by itself. If you can't find X by itself, it means you can't find the point of intersection. If you can't find a point of intersection, what does that mean? About these 2 linear lines. What does it mean? If you can't cross it out, if you can't find the A inverse, what does it mean? Daniel? Fantastic. It's only either parallel or the same line. That's the only time you can't solve. So the examples I give would be like y equals 2x plus 1 and y equals to 2x minus 1. If I asked you to solve that, you can't. Even if you equate them, if you did 2x minus 1 equals to 2x plus 1, you try to solve for it, it's going to cancel out to be negative 1 equals 1. It doesn't make sense. So you can't solve for x and y. The only time you can't solve for x and y, meaning you can't find what x equals to, so you can't find out the coordinates of intersection, the only time that happens is you either have 2 parallel lines or they're exactly the same lines. So what I gave you here is 2 parallel lines and I asked you to solve it. you'll likely find that you can't solve it. And if you can't solve it, well, it's because it's parallel, of course. They don't intersect, so of course you can't solve it, okay? Or if it's the same line, you have too many possible options, that's why it doesn't work, okay? Does that make sense, or what I'm trying to describe there? Because that's really the gist of chapter 2. You're going to apply that to answer this question here, okay? Now you got question 6 is from your textbook. I did question 5 in the last lesson, but I thought I'd do question 6 in class as well. I'll give you a bit of time to do exercise 2F, and then I'll quickly explain 2G. 2G is very quick and easy. I can explain that in 10 minutes. You just need to understand this. You understand this idea, then doing this question is easy, okay? And then doing 2G is all right. And that summarizes chapter 2, okay? So let's have a look. Find the value of m for which the simultaneous equations. You got this m plus 3x plus my equals 12. M minus 1 times x plus m minus 3 times y equals to 7. They want you to find have no solution. Now what does have no solutions mean? It's always key. What does have no solutions mean? What does it mean when we say have no solutions? Can I please have Luke?
When it has no solutions, that means that they're parallel.
Yeah, they're parallel, because that's the only time where two straight lines, remember this is two straight lines, x is to the power of 1, y is to the power of 1, that's a linear equation. Okay, this is a linear equation. So when do two linear equations have no solutions, meaning that they have no intersections or nothing that equates with each other, it's when it's parallel. They never meet, they never cross, so hence why you have no solution. So really they're just saying, when will you have two parallel lines? What m values can you have to make these two parallel, meaning same gradient but different y-intercept? That's your goal, okay? Now you can do that on a calculator, which I'll show you as well, but right now I just want you to do it mathematically. We've learnt matrices. We've learnt matrices to learn how to do this problem. So we've got A inverse over there, but the first thing we need is to change these two linear equations into a matrix form. So how do we do that? How do I change, how do I change m plus 3 times x plus my equals 12, and the second equation, how do I change this into a matrix form? Because that's what I need. I need this equation. This is what I need. I need ax equals to b. That's what I want. How do I change that?
M plus 3 a.
Good.
Then on b.
Yep.
M minus 1.
Good.
M minus 3.
Good.
Then times xy equals 12 and 6.
Fantastic. This is just using what you understand about matrix multiplication. Actually, I'm just going to move this a bit down so you don't mix them up. I'm just going to move it down here. Okay, so what I've done, or what she's done, is we understand it's something times x and something times x here. Now this is row 1. We can think of it as row 1, row 2, and you got column 1, which is your x variables, and in column 1 the second term is your y variable. So that's what we're doing. We're saying, all right, m plus 3 times x, that's row 1, times m plus 3 times x plus m times y, which is what this left line is here. And then that's meant to give you the entry for row 1, column 1, which is 12. That's why it's 12. Yeah, row 1, column 1. That's why we can see it. If I write it down, I'm going to highlight it so you can see. Row 1 times column 1 should give you row 1, column 1, which gives you the answer for that spot. And how do you find that when you multiply them? M plus 3 times x plus m times y, what this says, equals to 12. And you can do the same replica for the second one. This is row 2. First entry, you're multiplying an x, so m minus 1 times the x plus second entry times the second entry of the first column. So row 2, column 1, which is corresponding to this 7 here, that's now saying m minus 1 times x and m minus 3 times y gives you 7. So this matrix right now represents the two linear equations up here. Okay, so that's the first step. Now that I've got my matrix form, what you can see is this represents my A matrix, this represents my X matrix, and that gives my B matrix. And as we said, our goal is to find X and Y. But remember, X and Y is your point of intersection. So your job here is to solve this matrix problem. You've got A times X equals to B. Your job is to get X equals to something. The only way to do that is you need to remove A. And the only way to remove A, what do you have to do? Inverse, fantastic. So we know if we can find the A inverse on both sides, remember if it's on the left of A, then it has to be the left of B. Yeah, so I'm doing A inverse times AX, A inverse times B. And what we hope is that if the A inverse does exist, this should cancel out and I get X equals to A inverse B. That's what I want, okay? So the first step is, can I get an inverse? That's what I don't know. I don't know if an inverse does exist. But we know that when it won't exist. The only time it doesn't exist is when? When will you not have an inverse? When will it not work? Yeah, when the determinant equals 0. So all you have to look for now is this is matrix A. Your determinant, which is over here, AD minus BC. We're just checking if m plus 3 times m minus 3 minus m times m minus 1, does that give you 0? And what values of m will I get 0? Because once you know what values of m that makes it 0, you know the inverse won't exist. If the inverse doesn't exist, you can either have a parallel line or you have infinitely many solutions. See what I'm trying to say? It's just like a sort of a dominoes effect. Yeah? So the very first step answering this question is once you got your matrix form, all you have to do now is you say, all right, well, let's check if I can find the inverse by doing the determinant. Determinant is AD minus BC. And I got here A, which is m plus 3, multiplied to D, which is m minus 3, minus B, which is m, multiplied to m minus 1. We're going to try to expand this. Expand, simplify, yeah? So we want to know if the determinant equals to 0. That's what we want. We said determinant of A, if it equals 0, what are my m values? Now you can sit here and trial and error, or you can try to use some sort of algebra to figure out what m could be, yeah? And what we can see is that kind of looks like a quadratic equation right now. So it's likely that you're going to be using quadratics to solve for m. Yeah, so I'm going to expand that. Let's expand this. That gives you, I'm just going to take this step here. So 0 equals to m times m, which is m squared. Negative 3, actually that's a difference of perfect squares. So that's a minus 9, or no? Yes, minus 9, minus m squared plus m. So that conveniently not become a quadratic problem. I've got now m minus 9. So therefore m has to equal to 9. Did I do anything wrong? Almost feels too good to be true. Usually you have to do quadratics to get 2 answers and then you have to verify it. So it's unusual you get 1 answer. Alright, but now remember this doesn't tell me that I've got an answer yet. This just tells me m equals 9. Right? That tells me when the determinant is 0. If the determinant is 0, you have no inverse. But it doesn't tell you whether it's parallel or infinitely many solutions. It doesn't tell you it's the same line or parallel line. So how do you find out? What do you got to do? Sub it in. Because that's the only way. You want to check the 2 lines. Are they parallel or are they the same lines? The only way to find out. Because right now all you know is when m equals 9, that's all you know. When m equals 9, you just know you can't find a coordinate of intersection. That's all you know. That's all you know. Okay? So the only way to prove it is you go back to your line and say, all right, well, what if m was equal to 9? What do I get? Okay, so your first equation now becomes 9 plus 3, which is 12x, plus 9y equals to 12. Whereas the second equation is 9 minus 1, which is 8x, plus 9 minus 3, which is 6y, equals 7. Rearrange it, check if they're the same equations or not. Okay, so I'm just going to take this line and I'm just going to move it away. So let's move this down so we can analyze it. Here we go, let's analyze that. We've got 12x plus 9y equals 12. If you rearrange it, you get what? This is 9y is equal to negative 12x plus 12 divided by 9. So negative 12, that's what? Negative 4 on 3. X plus 1. Yeah, so that's my equation. Your next? 4 and 3. 4 and 3? Oh, you're right too. I was testing you. Exactly what I was doing. Okay, and then the second one, we check as well. We say, all right, if I rearrange the equation, you got 6y equals to 8, negative 8x plus 7, and then y is equal to negative 8 on 6, which is negative 3 on 2. No, wait. Negative 4 on 3. X, and still testing. And then plus 7 on 6. So what you can see here is by comparing the two equations, when m equals 9, then you get two of the same gradients but different y-intercepts. So that implies these are two parallel lines. Yeah, so if they're parallel lines, it means it has no solutions. And answering the question now, you can say, therefore, it says find the value of m for which the simultaneous equations have no solutions. That's when you say here, say therefore, when m equals 9, there are no solutions. Okay? But you can see why there's steps there. You see the manual steps to it was pretty straightforward. I'll just leave it there. You see the manual steps, on that side there was a theory, what I was trying to describe. Here you just start off by writing as a matrix, so you can find A, find determinant of A, simplify it down when determinant equals 0. So if it equals 0, you have no inverse, no intersections. Yeah? Solve for m. In this case it was easy, m equals 9. So if m equals 9, you don't know if it's the same line or parallel line, so you got to test it. Test it by subbing it back into the two linear equations. And that's what I did. I checked it, and yes, they are parallel. So if they're parallel, therefore, when m equals 9, you have parallel lines, hence no solutions. How's that feel? Pretty good? Because that's all you need to know for chapter 2. That's exercise 2F, and you're going to be doing the same thing for 2G, just with 3 variables, 3 dimensions. Same idea. Okay, but you're doing a calculator. Cool? All right. Now, how do you do it with a calculator? The problem with the calculator is it doesn't work out infinitely many solutions easily. It does well for no solutions. It doesn't do well for infinitely many. That's why I'm encouraging you to understand how to do it manually. And if you can do the calculator, it just helps it quicker. Okay, so if I were to do this on a calculator, let's have a look. My equation's up here. I'm going to go back to the equation. You got m plus 3 times x. I'm going to type it here. I want you to solve, so menu 3, 1. You want to solve for 2 systems of equations. So you got 2 of them. First one was m, what was it again? M plus 3 times x plus m times y equals 12. Now, be careful here when you type into your calculator. Don't type my without the time symbol in between. So notice I've got that dot, which means times. If you don't put the times in, the calculator thinks my is one variable. They don't know that m and y are 2 separate variables. That's why in my layout, I always put the times between them. Okay? Just to, when you write 3x, they know 3 is a number and x is a variable, but if you write a letter with a letter, they don't know. Okay, so if you do end up doing the exam or your SAC, if you get an error, okay, and you're pretty sure about your calculations, check if you have the time symbol, because I've done that so many times in the year 11's methods exam. And I walk by and they're saying, I can't get an answer, and I'm looking at it. I know what they've done wrong, and I should be telling them, but I do. I'm like, just missing a times, you know? But in the year 12 exam, you don't get told. So if you can't get it right, they're not going to tell you that you're missing a times. You just got to pick up on it. Learn to read, proofread your syntax. Okay, so times, just get in the habit. I always put the times in as a sort of my habit. Okay, so here we go. Next line, we got, what else do we have? We got m minus 1 multiplied to x plus, and this again, m minus 3 multiplied to y, whoops, equals to 7. Now here, remember, what are you trying to solve for? You're trying to find the points of intersection. How do you find the points of intersection? You're going to find x and y. That tells you the x coordinate, tells you the y coordinate. So that's what I'm going to do. I'm going to say comma, x, comma, y. So I'm saying find out x, find out y, if these are my 2 linear equations. All right? And if you press enter, what happens here is it tells you what x should equal to. So this will tell you, it doesn't matter what m is, you will always have an answer for x and y, meaning you get an x and y coordinate. If you get an x and y coordinate, it means you have a point of intersection. The question is, when will you not have a coordinate? So looking at these two, analyzing using chapter 1, when will you not have an x or y coordinate?
When degree is the same, I'm not sure.
No, I'm just talking about these 2 equations, just analyzing it. When will this be undefined? Because we're trying to say x will equal to this, x and y will equal to this. It seems like you always get an answer, but when won't you get an answer? Jack, 9. Yeah. See, the problem is if m equals 9, 9 minus 9 or 9 minus 9 becomes 0. So x equals to whatever it is on the top, doesn't matter. As soon as you divide by 0, it's undefined. So when is x undefined? When m equals 9. But what does it mean when x is undefined? It means you can't find an x coordinate. If you can't find an x coordinate, it means you don't have a coordinate of intersection. Does that make sense? Yeah, so you're just saying, when will the x coordinate not be there? So you can see why this calculator method is quick and easy for you to analyze, but the problem with it is it's best to find no solutions because you're trying to find when it doesn't work. Whereas infinitely many, it always works. It's just that you have so many of them. So they wouldn't tell you that. That's why doing it manually, you'll find out infinitely many. No solutions is best to do with a calculator. It does it very quickly. So you can see, it tells me m cannot be 9. Okay? The reason why I emphasize this is, you know the example I did yesterday, which is question 5. I'll show you question 5. Where is it again? Question 5. When you do this and you calculate it, m actually equals to 3 and negative 5. Okay? Negative 5 will give you infinitely many, and m equals 3 will give you no solution. But the calculator, when you type this in, it's only going to figure out the denominator. You're only going to see that when m equals 3, you get no solutions. But they don't have an answer for negative 5. And you won't know that unless you know how to do it algebraically. Okay, so I'm just showing you, it's always best to do it mathematically first, and calculator-wise, it's only to help make it more efficient. Okay, so just be careful. Infinitely many solutions, the reason why it doesn't come from your calculator, because it works. Infinitely many solutions means there are solutions, just there are so many of them. Whereas this one, we were looking for when doesn't it work. And it's easy to find when it doesn't work. It's hard to define when it will work, right? But that's exercise 2F. Do we have a better understanding of 2F there? Any questions? Yes, Jack?
So when would we use the calculator? Because I mean, if we use the calculator, we're still getting it wrong. Why are we using the calculator?
I don't know. See, this whole chapter, most of these questions were from the previous textbook, which you had to do it manually. You had to learn how to write it as a matrix form, and then from the matrix form, you would do what I basically did with you here, with the matrix form, and you go through your determinants. But since they changed that course and they said that it's not required, the textbook also changed, but they kept the questions. So the questions are now, so when you do it, you calculate, yeah, true, you can do them, but it requires now another level of thinking. You have to double check a lot of things. So that's why I'm saying if you just learn this algebraic method, doesn't matter what you get, you should be able to do it. It's just that when it's no solutions, you know you can do with a calculator. Infinitely many, I don't know how you're going to figure that out. It's one of the students for question 5 they did was, instead of solving for x and y, they solved for m. So you're trying to find when will m exist, and then you'll find that the only time that m doesn't exist is when it's negative 5 and some other random variables. I don't know if that's a legit approach. It seems a bit random and it just happens to work for this equation. So I'm not suggesting it as the approach. So hence why I'm teaching you this approach and giving you the idea of what you're doing with the calculator. You're just solving for intersections.
So on the exam, is it
yeah, most of the time the exam questions are pretty straightforward, especially with the multiple choice question. Most of the multiple choice questions, I don't even use the calculator for matrices because all I'm doing is I'm just doing AD minus BC. The only time I use a calculator in exam 2 for the multiple choice is when I have to expand it. So you know when you get up to this step here, I would have done A times D minus B times C on a calculator and it would have simplified it for me, and then I would have done factor and solve for m. Instead of doing it by hand, I would have done a calculator for those steps there. So everything I'm doing here, I can do it on a calculator. But I wouldn't just say solve these two and rely on that, especially if it says infinitely many solutions. I wouldn't rely on that. But I would use calculator for these. Instead of taking your time to write it out, I'd expand, factor, solve, and then get my answers from there. That's how I would do it. That's how I've been doing it, actually, so for the exams.
Sometimes would that take longer than actually writing it down?
Could. Depends on how fast you are. So because I do it on my laptop, obviously it's fast, but I'm assuming you guys, by the end of year, you should be more proficient than me. Your fingers on those calculators should be much faster because you guys have so much more training than I do. In fact, by end of year, you should be faster than me when you're doing the exam because I don't do the exam. I haven't done it since year 12. I only do it when I'm sitting here and I'm explaining with you, but I never actually sat down for a full hour or sat down for 2 hours to do your exams. So my exam techniques are not as good as yours. You should be much better than me by end of year. And it happens. The top kids that get 45 plus have always been faster than me by end of year. Because I have the knowledge, I just don't have the practice. You guys don't have the knowledge, but you will have the practice. Yeah, that's the difference between you and me. So I got the knowledge, I can tell you everything. I have a lot of time to do it. You don't. You have to learn to use your calculator, be efficient, be accurate, and I'm trying to pass my knowledge to you. But I don't have the speed. So if you and I sat down end of year and we were to compete and you were somewhat at the same level as me, knowledge-wise, we shouldn't be far off. If not, you should be better than me. That's how it should be. Cool. All right. But having said that, I tend to beat my students anyway, so challenge accepted. All right, that's exercise 2F. I'll talk about 2G about 15 minutes before end of session, but I want you to start on 2F. If your basics, so if your algebra, any of the algebra so far was not good, 2B and 2C is good for that. Otherwise, go back to 2E for matrices. So if you haven't done special, if you don't know matrix, multiplication, addition, can't do the inverses, do 2E, okay? Because that's important. 2E will be important for your SAC or your exams. They use 2E and 2F as your main sort of assessments. Not 2B, not 2C. 2B and 2C is just your coordinates geometry that you've learnt back in year 9, 10. Okay, so there's no point doing it unless you're really not good with your algebra. Then work on that, okay? All right, so remember, study smart, don't